Okay, let's dive right in. We're going to break down one of the most fundamental concepts for making any application grow: database replication.
So when your app suddenly blows up and gets super popular, what's the very first thing that starts to creak and groan under the pressure? Any guesses what it is?
Yep, you guessed it, the database. It quickly becomes this massive performance bottleneck that slows everything down for everyone. And even worse, it's a single point of failure. If that thing goes down, your whole app is just gone. Toast!
To really get why this happens, let's actually walk through the life of a typical app as it grows. We'll see exactly where things start to go off the rails.
You know, what's so fascinating here is how solving one problem often creates a new one. You start out simple, right? Everything on one server. Then you get smart and separate the web app from the database so they can grow independently. You even throw in a load balancer to make your web servers tough. But look what happened. We've made our web part super resilient, and now the database is just sitting there totally on its own and totally vulnerable.
And this right here is the big dilemma. I mean, sure, it's simple. It's easy to manage. For a while. But you're dealing with two gigantic risks. First is that dreaded single point of failure, the SPOF. If that one database server trips and falls, the entire show is over. And second, as more and more people start using your app, they're all trying to read data at the same time, and that poor little database just slows to a crawl.
Okay, so how on earth do we fix this critical bottleneck? Well, this is where the hero of our story makes its grand entrance: database replication.
The core idea is actually pretty simple, but it is incredibly powerful. Instead of making one database do all the heavy lifting, we just make copies of it. We divide up the labor. And this, right here, is the first step towards building a system that has high availability and real redundancy.
Now, the most popular way to do this is with something called the master-slave model. You might also hear it called the Leader-Replica model. The easiest way to think about this is like the master is the original official document. It's the only place you can make changes. It's the single source of truth. The slaves, well, they're just read-only photocopies. You can hand out thousands of these, and people can read them all day long without ever bugging the person who's actually editing the original.
And this table just lays it out perfectly. It's all about separating the jobs. All the tough stuff, the writes, the updates, the deletes, that all happens on the master. But all the reading, that gets spread out across the slaves. And this is a huge win, because for most apps, you're doing way more reading than writing. I mean, think about it. You probably scroll through 100 social media posts for every one you actually create, right? So by offloading all that reading, we can scale up our read power just by adding more copies. It's brilliant.
Okay, let's make this super concrete. We're going to trace a couple of user requests to see how this all fits together into a tough, resilient system.
Okay, so you're just browsing your feed, maybe looking at a product on a shopping site. That's a read request. It hits the load balancer, gets sent to a web server, which then asks one of the slave databases for the info. It's fast, it's efficient. But now you want to make a post or you decide to buy that product. That's a write request. That goes straight to the master. The master records the change, and then it's its job to automatically update all the slaves so they have the brand new data.
All right, so we've gone through all this work. What did we actually get out of it? Well, the payoff is huge. We've just unlocked some massive improvements in performance, availability, and just plain old reliability.
So the final result isn't just a faster system, it's a fundamentally stronger one. If one of your slave databases goes offline, no problem. Traffic just gets rerouted to the healthy ones. That's your high availability. With all the reads spread out, performance just skyrockets. And because your data is copied in multiple places, it's way safer.
But it's not a perfect system. There's still a pretty big weakness here. What is it? Well, we still only have one master database. And if that single master fails, we can't write any new data to our system at all. And that brings up a whole new can of worms.
So to get around that single master problem, we can turn to another model, something called a leaderless cluster or a multi-master system. The name kind of gives it away, right? There is no single boss. Any server in the group can take a write request, which completely eliminates that single point of failure for writes.
And this brings us to a classic trade-off in system design. With master-slave, writes are simple. They all go to one place. But if the master dies, recovering, what we call failover, is a real pain. You have to step in and promote one of the slaves to become the new master. Leaderless systems, on the other hand, failover is a breeze. A node goes down, the others just pick up the slack. But now you have a brand new headache.
What if two people try to update the same thing on two different servers at the exact same time? Now you've got a data conflict, and trust me, figuring that out can be a total nightmare.
And that right there is the absolute key takeaway for this whole thing. When it comes to system design, there's almost never one single right answer. It is all about understanding the trade-offs and then choosing the right set of compromises for what you're trying to build.
So just think about it for a second. Your banking app, does it prioritize having the absolute 100% correct up to the nanosecond data every single time? Or think about your favorite social media app. Does it prioritize just being online no matter what, even if your feed is maybe a few seconds out of date? That choice, that fundamental choice between consistency and availability, that's what often dictates which one of these replication models is running behind the scenes.